little lagging. So yeah. Okay. Anyway, I'll start. Okay. So yesterday we were at here. So I will little bit revise that one. So I said we have communication between main peak and reset peak. So the data or the command or data going to the reset peak from main peak is 9 bytes. Okay. So you can see 9 bytes. So this method is not there in the burst 3 code. Burst 3 uses only 1 byte, okay, because it's not so properly written code and is not so advanced. This is a better method we use in Kitsune and later satellite, okay. So 9 bytes array goes, and the array looks like this. So we have, actually, sorry, I made a mistake here. 9 bytes, if it is actually not 9 bytes, sorry. It's actually 10 bytes, okay. Sorry, I made a mistake here with the 10 bytes. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And first one is the header, and then this one is the footer. So the reason we use header and footer, using header we know there are data coming, and using footer we can make sure all packet or command received, okay, complete packet or command received using footer. We we we, we confirm using footer. So I will give one example command, okay. Example command. So command 1, I told you last time, every time, not every time, every 90 second, main pick request housekeeping data or plus same command is to tell reset pick main pick is properly working, whether main pick is properly working or not, okay. I will show that command how it is created. So the command is b0 a0. This first element of that array used as the uh, command identifier. So we can say this one is identifier, okay. So other things don't care, like just normal. If you have something else, you can put in this byte, but we don't have anything here for this command. I just, if the reset pick C B0 B1 and this one reset pick knows this is the 90-second communication command. So what reset pick does is, so reset pick reset the counter related to the main pick, and reset pick will respond back the housekeeping data, okay. Now let's go and see how it is done in the code. So if you come here, there is a function written here, there's a function, its name is check UART incoming from main pick. So it check whether there are data coming from main pick. So, and then if data is received, that data is saved in the main pick to reset pick array, okay. And then we can check those byte values. First we check the 0th element whether header has received or not, and then we check whether footer has received or not. If these cases are okay, the program will go inside this loop. Okay, so the first command is respond to the main pick 90-second command. So let's go and find that function. So it's written in the reset pick main pick. So respond to main pick 90-second command. Here in that function, I check whether the first element is A0 or not. If that is the case, it will run things inside here. Otherwise, it will go to the second and check and third and fourth and fifth. Okay, so you can see what those command identifier values here: A0, 70, 71, 72, 73. I will explain these things later. First, let's see this A0 command. Okay, here first you can see it check the whether A0 or not, and then it goes inside the this loop. Okay, Yes. Then you can see first thing I do is I reset the main pick counter. Last time I told you if this main pick counter reached to 600, which means reset pick thinks main pick did not reply for uh, for 10 minutes. Okay, then reset pick will reset the main pick. But right now, since the main pick send a command to the reset pick, I make this counter 0. So then after that one, it will start from 0. In every 1 second, this will increase by 1. And then I print what command received from main pick in the debug line. So you can see I print 90-second main pick command. And then same time I print the command received to reset pick from main pick. Okay, this is just printing. You can go without this one if you want, but the problem is for the debugging it's better to have that one. And then so then I need to I need to reply back with the housekeeping data. The format I sent back is this one. So the reset pick, I'll write reset pick reply or the housekeeping data array. So it will have, wait, I don't remember how many bytes. Okay. It is a 36 bytes reply reply or okay, reply. The format is 0th element is B0. I use the same header and footer for this case. Okay. So then 1, 2, 3, it goes like this. And the 35th element is B1. This is the footer. Oh, sorry. If you don't see what I write, please tell me. Okay, I did not see. You can see the screen?
Can see.
Sorry. Again, I will explain. So reset pick reply is a 36 byte reply. So it will have 0th element is B0 and 35th element is B1. So this is the format of the reply. Okay. Now let's see what are these values inside this array. Okay. So first thing, using this function, I make that respond array clear first. Okay, basically I make all the values to 0 0 0. So initially everything is 0 0 0. If I do that one, it happens. If I run this function, it will happen. Okay, So then what I do is I measure different uh, ADC value. First thing is I measure raw power. So raw power ADC value. Actually, raw power ADC value means the raw power here. Wait, you remember? I check the raw voltage value. Okay, using this function. There's a function written to get that voltage. Okay, after explaining this part, I will show how I get these ADC values. Okay, first just think you get the ADC values here. Okay, and then 3v3 current one using this function. Okay, normally when I write a function, I will just write the exact name as the function name. So it's easier when you read the code, even though you don't have any comment. Okay, you can see here even I just wrote the thing happen in this function as the function name, and then 5 volt measurement and 101 measurement, 102 measurement, everything is done. And one thing you need to remember all the values below are 16 bits. It's not 8-bit. Okay, so then first thing need to do, I need to assign the header. So it's very simple. You can say I assigned it, and then I put the command identifier back in the uh, array. So previously I said the command from main pick to reset pick has this command identifier. I send it back. Okay, because if I send it back to main pick also know which command, which reply for which command. Okay, and then next what I do is I put the year, month, day, hour, minutes, and second when in that packet. Okay, use it actually in that response. You can just say packet also. So using this one, we can get at what time these reading were taken. Okay, maybe there are few millisecond difference between the reading taking and this assigning, but it's okay. It's not it is not taking more than 1 second. Okay, then in the eighth element I put the raw ADC value even in ninth element. Okay, so these values are 8 bits. Since I have to break this raw ADC value into two parts, you can see here using this one I take the so let's say we have ADC value like 0, 1, 2, 3. Let's say that is ADC. The way I extract this part is ADC. You have to shift 8 bits into this direction and take and with this value. Maybe you remember we did similar thing in the flash memory also. Then unsigned int 8. Okay, you have to convert. So same thing is done here. So it's okay. You can, it doesn't matter you do this one or just take effect. Okay, similar way we break the other current values. Okay, here unbreak one, and then you need to remember these things don't take too much time. Maybe it's like by 1 or 2 microsecond. Okay, these are very fast. It's assigning. Okay, don't need to worry. So then 20th element we put the compik reset counter. So the same counter which is used to check the compik and main pick uh, health. Okay, then main pick reset counter. You can see I explained yesterday uh, there is a variable which has power line status. Okay, and then 23rd element I just put AA. Okay, just to tell where the data finish. Okay, and then from 23rd to 34th I did not do any assignment, so it will be 0 0 because in the beginning we make all the things 0 0. So now you can see I have not used from uh, 24th element to 34th element, so about 10 bytes are empty. So the reason I kept this 10 bytes are for if you need to send more data in future satellites, you can use these 10 bytes. Okay, this is, so you can use those bytes future if you need. Okay,
The one is those are extra one, is it?
yeah, extra. So it was very helpful when we write the bus x, because bus x needed about 30 bytes. Since we had this kind of a bigger array, we could use easily. Okay,
Okay, noted. Thank you.
and then at the end I put the footer. Okay, very simple. Using this for loop, I send the this entire array to main pick. You can see I started from 0 to 36. Very simple. Then you must remember you have to make this main pick to reset array 0. Okay, so the reason is this one. So function was executed here, and this is not a correct condition. This is not, because we received a0. Okay, and then here and it will come out of this place. Okay, and it will come here and it will go here. Since we did not delete it, again this function will run. Okay, that is not good. So because of that we have to clear that array. That's why we have this function. So if you executed basically if you executed a command, please clear that command. Okay, otherwise it will be keep executing. So that is not good. Okay, so did you understand this part? And then I told you we need to and I told you I will explain this ADC functions. Okay, you remember using these two lines in the settings loop, we enable the ports. Let's see how we read the ADC. In pick cases, I'm not sure. In pick cases, we don't have many ADC modules, even though we have many ADC pins. So it's like this. So we have, let's say, and 0 pin, and 1 pin, and 2 pin, and 4 pins. So we have 4 output pins. So if you see this one, you see like there are 4 ADC modules, but these are just 4 ADC pins. Okay, we have only one ADC block inside this peak. So it's a here switcher, and then we have the ADC output. We have only one ADC taking module inside the PIC, and if we want to read this ADC port, so you switch this one to here and wait some time and take the ADC reading, and here, like that. Okay, so understand?
Yeah,
Okay,
understand.
yeah, then we go to the reset PIC ADC. Here you can see here, if you go here, before explaining this one, this measure raw voltage value, I'll just explain this measure 3.3 current value. Okay, so
Okay.
to store those ADC values, I have defined 16-bit variables. Okay, so we have only 12 bits ADC reading, but there are no 12 bits variable in C. So because of that one, we need to have 16 bits variable. Okay, that's why I have defined like this. And the first thing is here. No, measure 3.31 current. Using this line, set ADC channel, I switch the ADC channel 1 to this ADC module. Okay, you can see, and then it says wait about 20 microsecond, and then return ADC reading. Okay, and if you want to measure the line 2, set switch to the line 2 and delay 20 millisecond, no, microsecond, not millisecond. Okay, it's very fast, and read the ADC. So it's the same way done for all the those current measurement lines. But here, the reason I did not explain this one in the beginning is, if we go back to OBC, so that is the raw voltage reading line. So you can see it comes to kind of an isolator, and then it's through here and goes to the peak. I told you, like, at that time we have to enable this isolator, otherwise this will not be connected to this side. Okay, otherwise it is disconnected here. Okay, so the first thing, we need to enable this one using this RB 5 line. Okay, so first we need to make that line high. So here, first output high or pin B5, and I just delay 50 microsecond. You don't need this one, but I just delayed. Okay, and then after that one, very easy. Set the ADC channel 0 and delay this one, and I take back the oh sorry, here it's not high, it should be low. I disable that buffer, then I can return the ADC value. So that's very easy. In this one, just additional this making the that buffer actually enabling that buffer and disabling. Okay, understand? Have you used Arduino? Has someone used? In Arduino, to get the ADC reading, you just have inbuilt function, but you have in this inside Pix, you have to create the functions by yourself. Okay, anytime if you want, you can run this function. Okay, so any question? Okay, then I will explain this update reset pick RTC by main pick command function. So the meaning of this one is this. Again, I just to make sure, do you see the screen properly?
Yes, yes.
Okay, thank you. So we have the reset pick, and we have the main pick, and we have the home pick. We have this communication UART lines. Okay, so home pick has the ground station. When the Compik have the antenna which communicate with the ground station. Okay, when ground station send the time update command, that command will go to, actually not the Compik. So this is, there's a transceiver here. It goes to transceiver and Compik. That command will go to main pick. Main pick time will be updated with that command. Okay, then main pick will send that current time to the reset pick to update reset pick time. Okay, that's why we need a command which update reset pick time by main pick. Okay, so the way I do is that format is, again we have how many, 1 2 3 4 5 6 7 8 9. So B0 and B1. Oh, sorry. And we have the command ID, different command identifier here is 70. And then I put here month, day, hour, min, and second. And this is not available. Not available means just it's 00. Okay, I don't care about that byte. So this is the command coming from the main pick to update the time. So then let's see how that function is written. Not this one. Check. Not system reset. I think I explained the system reset. Okay, here update reset update RTC by main pick command. Actually, this RTC is the reset pick time. So the first thing I check the whether it's 70 or not, and if that is the case, I print the command name and the command received. Okay, and then I have to acknowledge to the main pick confirming whether reset pick received the command or not. So the acknowledgement is this one. So first I erase the reset pick to main pick array, and then I put the header and the command identifier and the footer only. Okay, other bytes are don't care bytes. Okay, it can be anything, it doesn't matter. And then using this function I send it to the main pig, and then this is how I update the time. It's very easy. Just as put the uh, this second element value to year and third element value to month, day, hour, minute. Okay, that's it. And then after that one I print the current time. It's very simple. And then finally, as I told you before, we have to erase the command received from the main pick. Okay, that's simple. Understand?
Understand.
Okay, then we have, if you read the next function name, you will understand what is it. Reset pick power line control using ground station command. So what happened is, similar to previous case, using ground station command we can enable or disable the power lines in the this satellite. So you send some command to the config, it will go to the main pick, and that will be transferred to reset pick. Okay, so which means that command should go from main pick to reset pick. So there should be a format. Let's see that format.
Sorry for interrupting. You mean receive the command from ground station can directly go to main, and then from main go to reset?
Reset pick, yes.
Okay,
But
thank you.
you can see there is another path you can do. Okay, you can send directly here through this path. So, but we did not use that one because this main pick keeps some log. So main
Sorry,
pick
you say keep what? Keep what?
log. It
Log.
record which command received from the ground station. Okay.
Okay.
So if you just send it here, main pick don't know whether there's a command received or not from. Okay.
I see. Okay. Mhm.
Okay. If you, I'm just giving.
Notify the main pick lah. Okay.
Yeah. Actually, this is the path. So if you like, if you feel that is very complicated, you can send it here, and maybe you can maintain a login config. I'm just giving ideas. When you program, just think different ways. Okay,
Okay.
so I suggest you to use the old codes, but I don't suggest you to just use as it is. Okay, please try to create new things and try to make the things simpler. Actually, I don't like this method because you need to create a command here, you need to create command here, because it takes time to go here, it takes
Too long, right?
yeah. Basically this is what happened. It goes here and main pick send the acknowledgement here, and then main pick send here, reset pick send the acknowledgement here. There are 4 communication happening. Okay, there are
Okay.
4 there are 4 methods of failures right now. So it's better if you can do this one. In birds X, it can do.
Okay.
Birds X don't maintain any log.
Okay.
So we maintain the log in the ground station.
All right.
In the earth. So we directly send some command direct to here to update the time. It will send here. So then, right? So okay, let's see that case. If you send time to here, reset pick time will be changed. Okay. Now main peak time and reset peak time is not equal. So the way it synchronizes is like this. You remember in every 90 seconds it send a request here. So
Yeah,
as
yeah.
as you remember, uh, just few
Agree.
minutes ago, there is
Ah,
a reply coming with the time.
mm,
Before saving the data, main peak check whether that time is similar to the main peak time. If not, main peak update its time. It's not a different function. Just use another function to update the time. So you can play with this one. You can find a way to change the time. You can do something like this also. So let's say it comes here. If reset peak update at the time, reset peak can send a command to the main peak to change the time. Instead of doing that one, I wait some time until this 90-second communication happens.
seconds. Yeah. Mm,
Okay.
okay.
So basically, uh, please use the burst 3 kitsune, those code as a reference. Try to create your own code because as I heard, this is not going to go into this space. This is the testing model. You can learn different ways of doing these things inside the satellite. Okay. If I try to write another, if I use this system for another satellite, maybe I will find another. I will get another idea to do this communication. So always find the best solution. Okay, let's. Okay, I was explaining the that power line control. It comes here. Okay, I could send it here, but there's no function to do that one. So the method is, let's find that function here. So the first thing, I print the function name and then acknowledge. Okay. Now you can see if the main pick to reset array second element is this one, I turn on the 3.3 one line. Other, if not, else case, I turn off. Okay. If the third element is one, this 3.32 will be turned on. Uh, else it's off. It's similar for the other lines. Okay. You can see there's something else here. Okay. You cannot control the unreg one line using a command. Reason is, okay, that's a, you have to think this kind of things also. Okay. So we have the transceiver here. The satellite on off command, satellite power lines on off command comes to this one and to transceiver and goes to compig. Okay. Wait, I need to close the line, otherwise I will get disturbed. So this transceiver is powered using unreg 1. Okay, let's see someone accidentally, let's imagine a case where we can control unreg 1 line. Okay, let's say someone accidentally send a command to turn off the unreg 1 line. So initially command will go here and go to main peak and go to reset peak, and reset peak will turn off the unreg 1 line. So which means our transceiver is cut off. Now it's a huge problem if you don't have a recovery method inside your code. in entire time this will be turned off. So which means it's like your satellite is dead. Even though these things are running, you cannot communicate with the satellite because Android one is off. So that's why to avoid that kind of situation, I did not even put that function inside the code. Mistake can happen. Someone who don't understand these power lines can send this kind of wrong command. So because of that one, I did not write any code to do that one. So then it is safe. Okay. Then again, I erase the uh, received command. Okay. Then there is a function. This control C sarc power by main pick command. So that is no need to know because it's the similar way. Again, it check whether it's 72 or not and do that power line control, and then turn on CSARC mission for it's related to that CSARC mission. So CSARC means actually chip scale atomic clock. So you can go without this, but this is one of very important function. Okay, this one is turn on 102 line for antenna deployment. It's like this. So we have the 100, actually we have raw power. Okay, so from raw power there is a OCP and this is 102. So there's a control line comes from here. And then this 102 is used to deploy the antenna. It used to give power to the burner coil. And we have a MOSFET here which is connected to ground, and there's a line which controls this MOSFET from main peak. Okay, so as you know, after 30 minutes from ISS deployment, we need to deploy the antenna. So the way it happened is there is a counter inside the main peak. Main peak check whether it reached to 30 minutes and tell to the reset peak, please turn on the 102 line. So then reset pick will acknowledge, and reset pick will enable this OCP, and 102 power will be coming here. And then main pick will turn on this one. This coil will be burnt. Okay. And then antenna will be released. Okay. So have you seen that mechanism? How it happens? Anyone? Okay, one more thing. After
I think yes.
okay, wait. After finish, reset pick will turn off this line. Okay, I'll show. Okay, wait. I need to show that mechanism just
Okay,
to
thank you.
get the idea. Give me a few seconds. Can you see the screen?
Yes.
So the our antenna element when it is deployed, it's like this, okay, this direction and this direction. Now it's wrapped around this mechanism, and there's a uh, nylon cable goes. What happened there? Nylon cable goes through this burner coil. So when this is heated, this nylon cable is cut, and the antenna will be released. Okay,
Yeah.
that's what I explained about in this circuit. Okay,
Yeah.
very simple mechanism. So 102 is used only for that case. That's why if you go here, if you go in this circuit, you can see this OCP value is 3 ampere. Okay, so we found out when the burner circuit is on, it is about 2.4 ampere flow in this path. Okay, if it is more than that, this OCP will be triggered. There will be no antenna deployment. Okay, so I want to draw something else also. It is not just there is a resistor, about 1 ohm resistor, to limit that current below the 3 ampere. So when it is on 2.4, okay, this is enough to actually when we turn on the burner circuit, uh, this coil become red. So it's even if you go here, maybe you can see is the coil is discolored because when we deployed it become very hot. That's why. Okay, these are just additional things. You can try this kind of things also. Okay, you can create some burner coil in your external panel with some antennas. Try to deploy the uh, that antenna. It's a very good practical and very interesting also. Okay, there are DIO lines assigned for that enabling. So here, this. So that command is D0. Okay. So if I go here, uh, it's somewhere here. Turn on 102 line for antenna deployment. So I check whether, and then you can see somewhere here it turn on the 102 line. Actually, you can put one instead of on. Okay, it doesn't matter here. And then I keep the line on about 30 seconds. Okay, within here not 15, and we found out 15 was not enough. Even though I keep it 30 seconds, it will be deployed within like maybe 10 seconds. You must keep it little bit long, otherwise before it burnt, you will turn off the 102 line. Okay, so that's simple reset pick code. And then let's see these variables. Okay, these are the main pick to reset pick arrays, reset pick to main pick arrays, home pick to reset pick arrays, reset pick to main pick arrays, and then main pick counter. This is used to check main pick status. That's 600 case. And then this is actually I want to explain. Okay, let's say because of some reason, if reset pick reset the main pick, let's say because of some reason, if the reset pick reset main pick, this counter will increase by 1. Okay, if reset pick no, if the this count main pick reset count, okay, If a reset peak reset another time, it will become 2, another time it will become 3, like that. Okay, same for the config also. When we download data, these values will be in the data. From ground, you can see how many time reset the main peak using these values. Okay, so normally when I program, I always try to not to increase this value. If I see there is a non-zero value in this counter, which means something went wrong in the main peak. Because of that, reset peak reset the main peak. So I will try to solve that issue always. Okay, and then the power line is status, that one. So you can see sixth bit is 3.3, fifth bit is 4.5. Actually, sorry. Okay, so it still has the Spartium power line. So 3.32. This is 1, 2, 5, 101, 102, config and main peak. And this is a CSAC things, no need. Okay, transceiver on related things. Main loop, main loop counter. Maybe you remember I explained yesterday. Here, using that main loop counter, I can create about 100 millisecond delay to toggle the watchdog timer. Those things. And then these are the variable used for the RTC. Okay, then this is the main pick software UART line definition. Okay, the data rate is 19,200, transmit pin and receive pin parity, how many bits, name, and I put this one to tell this is a software UART line. And then we have the debug UART line. It's a little bit faster, and how many, it only has the transmit pin. Okay, no need receive pin. Okay, stream name, those things. And then this is a new function for the hardware UART line. Maybe you will, I'm not going to explain, this is little complicated. You just need to use this read available those function. So it's similar to serial read and serial available function in the Arduino. Okay, if you read the Arduino tutorial, serial read and serial available is exactly similar to that function I created, similar to that one. Okay, and then actually this is the UART interrupt loop here. Maybe please try to understand this one. A little harder to understand, but please try. Okay, and then this I explained this one, and I explained, yeah, this is also explained. And here I print those print time function and everything I explained. Let's see how this run when we run it. Okay, so I have this pick in this one. Same this RB7 actually PGC line, that is the programming line. I use it as the debug line. Okay, transmit from pick to this serial reader. This will be your PC. Okay, if I run this one, so it will first print the boot in reset pick. Okay, then it will print the time in every 1 second. So the reason you don't see that 1 second, it takes more than 1 second, is this software is right now is not running on real time. Okay, if you go here, you can see simulation is not running in real time due to excessive CPU load. Okay, so if you run in the real system, it takes only 1 second. You can see it give the year, month, day, hour, minute, second, and you can see these are the, this is the main peak counter, and this is the reset peak, no, home peak counter. If this value reach to 600, reset peak will reset the main peak or home peak. Okay, then this value is the that power line status. So you can see 7F means 7F means 7 7F means in binary is 0 1 1 1 1 1 1. So right now all the power lines are on. Okay, so it's here. Then here it print the ADC reading values. Right now no ADC reading, so that's why it shows 0 0 0. Maybe we can turn off one power line and see whether that power line status change. Okay, okay, let's turn off the this one. If I do this one, it should become 3F. Okay, yeah, it became 3F. So in your PC you will see this debug line. Okay, understand? Now after this one, next thing I will explain to you is how to run this board initially and do some testing. Okay, understand?
Okay.
So here actually I just needed to show here. I check whether how much time it takes here. I said it's about 100 milliseconds. So using this kind of simulation, you can see how much time it takes to run 4,000 loops. So it's about 100 milliseconds because this one is 100 milliseconds. This is a reference source. So almost 100 milliseconds will take to toggle. Okay. So now let's say you got the OBC board. Let's say you got a OBC board. Right now you just have the board. You don't know whether this things works or not. We have main peak power line and we have home peak power line and 3.31, 3.32 and 5-watt line. Okay, 5-watt line. Unrig 1 line, unrig 2 line. So you can see so many lines. Okay, maybe you remember using reset pick we can enable disable the each line. Okay, let's say somehow some person took the board and give the raw power. Okay, actually we don't need the in the FAB the backplane board we have connectors like this. Huh? Any question?
No, no,
Okay.
no problem.
So we have FAB, we have OBC. So basically you have those two boards. Okay, you don't know whether OBC working or FAB working. Okay, in the beginning please don't plug the FAB board. Okay, reason is maybe FAB board don't work correctly. Okay, take out the FAB board, plug the OBC board here. Then you remember there is a line connecting from FAB to OBC, that is the raw voltage line. So You can connect a jumper to this pin and give the raw voltage from about 4 volt, and from somewhere you can get the ground also. Okay. Now you are powering only OBC. Okay. Basically you are giving power to this connector using some male jumper. Now OBC get the power. The thing is, since you have not programmed the reset peak right now, these power lines are not enabled. Okay. Let's say someone now programmed to turn on all the things. If I give my current code, so if you put this code inside the peak, all the power lines will be turned on. Since you are not sure whether these things are working correctly, things can go wrong. Okay. Let's say somehow you have short circuited something like this. So this turn on, something can happen. I heard in the beginning, so these two short circuited. So something can happen. So the thing you need to do is enable line by line. First, maybe you can enable the 102 line, because 102 and 101, because those don't have any buck boost converters, just enabling. If we go here, so 102 and 101 don't have any buck boost converter, just connection here. So you can check whether these OCP is correctly working or not. The way you do in the code, get this code. You don't need things inside this while loop. Basically, take this part and until the end, make it comment. Nothing happening in the code, but you have to do something else here. Okay, you need to make this no MCLR here. If you don't do it, reset peak will be resetted every time because of the external watchdog time. Okay, remember that should be no MCLR, but I remove that one. So let's say you want to turn on the 101 line, turn off every other lines. Okay, very simple. And then get a multimeter and check whether that pin has the output. Okay, in the OBC. So you come here to the correct pin, and using a multimeter you can check whether it has a correct output. Okay, understand? So even you can load the line and see whether OCPs are correctly working. So basically you just need to connect the electrical load, so and change the resistance value, then the current output will be changed. Then you can see where the OCP trigger. Okay, if you have any question you can ask. Basically this is the first thing we do when we get a new board. We isolate the board and power it and check whether it's working. Okay, if you have any question you can ask. Anything?
No, not for me.
So right now, can you please show your satellite again? I'll stop sharing.
I mean the which PCB or
Yeah, just show the photos. I don't know. Wait.
oh.
You showed me a previous slide.
Hmm. Hold on.
Okay, thank you.
The picture or something?
Yeah, picture. Okay. As I see right now, you have the exact dimension.
Sorry?
Okay. How?
The
Yeah. How many backplane boards you have?
no,
Only
only one.
only one?
Uh-huh.
It's better to have like two because you can do little bit hard testing on the other one. You can solve some wires to that board like that.
Uh-huh.
Actually, we had a bigger backplane in the uh, worst case. Can I share it again? I will explain that one. Okay?
Mm. I mean, but X.
No. It's in every burst project we had a different development board.
Oh, I see.
Okay. Sorry, my laptop camera is not working. I could show, otherwise I could show the real board. Maybe we can share that PCB design. You can make it, okay?
Uh-huh.
I will explain what is that. So we had a
Is it the hard wire or the
we had a
TPLP?
bigger board, like huge board.
Mm.
Not
Yes, yes.
huge means it's not so big, okay? Like I will draw the dimension. So normal board is like width is around 10 centimeters. But so let's say, so maybe this is 10 centimeter, okay? So this is about 8 centimeters, and we had those connectors, 50 pin connectors. It is little bit far away, okay? About 3 centimeters. Everything we place about 3 centimeters away. Okay, maybe this is FAB, maybe this is OBC, maybe this is communication board, and then some mission boards, other things, okay?
Mm.
So here we had like access pins. There are pins has row voltage and 3.3 voltage and 3.3 to like that. There are those things are connected to this line somewhere, okay? Basically, without touching this part, you can access through these pins, okay? You can give powers to here. It's a bigger development board. Understand?
Mm. Yes, yes.
So you just need to plug the board and you have the access to these pins.
Mhm.
Maybe
I think I saw it in the one of the presentation.
okay.
Like,
So I can share the PCB design.
uh-huh.
If you need,
Yes,
you can
please.
make that one. Okay.
Mhm.
It's better to have that one. Even when I try some coding now, I use that board because without damaging the problem is this one. Okay, let's say this is the FA model. Okay, so if you have the back plane, if you keep inserting some jumpers to those pins can get damaged. To avoid
Oh.
that kind of situation, we use this external access pins. Okay.
Mhm.
Actually, it happens in Bird's one of Bird's X EM model. So people were using these connectors to put jumpers, and after some time, hole became bigger. When the real board is plugged there, it's not touching correctly.
Mhm.
Okay. Those are just additional practical problems I explain. Okay.
Yes, yes.
So let's see how to program this board right now. So there are two ways. First way is programming. So we can see the OBC board. Let's assume we give the raw power. So right now, and then we have the power. The first peak you program is the reset peak. So we have the reset peak. As you remember, there is a very small programming connector. You can connect the peak kit to here and do the programming. Okay. As you know, this is little harder because this connector is very small. You have to create another adapter to connect peak kit to this connector. Okay.
Yes.
So, but there is another way. So we have the OBC and FAB. All the PGC and PGD line, PGC, PGD, those MCLR, many MCLR are there. Let's say this is COMPIC and the reset pick. Okay. So the way you program, let's say you want to program the reset pick, get the pick kit. You need to connect. First is MCLR, reset pick, and then 3V3 line you need to connect, then ground, and then PGD, PGC. So that's how it done. I think in your FAB you have the access connectors here. Is it correct?
Yes.
So somehow any kind of routing, those PGC and PGD comes to these connectors. Okay.
Mm-hmm.
You can connect some adapter cable and connect to the pick kit. Okay.
Yes.
That's the one method you can do. That is the method you have to practice actually. Always putting a connector here will damage the connector on the OBC. So if you go here, FAB, I think these are the access connectors. So this J1 connector has the PGD and PGC and MCLR pin, MCLR. Okay. And other connectors also, other connectors has different access things, like you can access the ground. And this is FAB to OBC. Okay. This is the OBC debug, actually main pick debug line external access pins. Okay. You remember in this one I explained, from main pick there is a debug line goes to outside. Actually this is that one, and there are some pins can be accessed, but these things are not meaningful. This is for future use. Okay, if you want to use this for something else, you can use. And these are very important. The connector is very important. Okay, the reason is you can using this connector, you can measure the battery voltage and raw voltage. This SRC voltage. SRC voltage means solar bus voltage. Okay, solar bus. Yeah, solar bus means if you go to the schematic, so solar panel input comes here, it is added here. This bus voltage we can measure. And here is the external power providing circuit connector. Okay.
Yes.
Please give correct polarity. Otherwise, actually, this will not damage because there is a diode to avoid that kind of situation. So if you use this place, you have to use about 5.4 volt. The reason is we have, this is where it comes in. So external power comes through this diode. This diode has a about 0.4 volt drop, and then about 5 volt will be applied to this input of the battery charger. Battery charger input voltage must be greater than this voltage. Okay, maybe I don't exactly remember this one. Don't, it's not 0.4, maybe 0.8. Okay, I'm not sure. It doesn't matter if you little bit give more voltage here. Okay, but don't go like 6 volt or something. It's not good. Okay.
Okay.
So then, if you have any question, you can ask. Like then I can answer because there's about half an hour.
Any question?
First
Is it
thing,
possible to, if let's say we face any problem, still can contact you?
yeah, it's better maybe. Can you create a like WhatsApp group?
Okay, thank you.
Yeah, like I can answer, but when I get a free time, I will answer. Okay, sorry, because
No
there are
rush, no rush.
yeah,
Yeah, okay, yeah.
like just it's better have WhatsApp group because it's easy to contact. Otherwise, writing email will take some time.
Yeah, agree.
Okay, so will you program this board? What is the method you are going to what is the method you are thinking to use for programming right now? Are you going to use direct connector or through this connector?
Maybe through FAB, but
Yeah, it's better. But
anyway, do you have? Can I have the part number of the
this one,
the no
this one,
the connector that you use to the female the male
male
connector.
one. Wait, I can. Okay, until
Then
I
you make a jig, right? You make a
so
jig, 5 connectors jig to program on the OBC board.
okay, the thing is this one. Okay, this connector is like, as I remember, the pitch is, so if you, I think you can see here. So if you look from top side, you will see something like this. Okay,
Yes.
so this pitch is about 1 millimeter. Okay, it's very small. Basically, this is 2 millimeter long a small connector. So if I draw the look of this one, it will be like this.
Yes.
Uh,
On the OBC board.
this is the male one I am drawing. Okay,
Oh, male.
so it will looks like this. Okay,
Mm-hmm.
so you need to solve the wires to here. It will be very small. The way we did was we had a small PCB. We placed this PCB is like a 1.5 centimeter long and same 1.5, and placed here. We and routed, and we solder the wires to this
Mhm.
and then plug it. So if you can do a better soldering, you can solder directly. Maybe put some glue here, okay? After that one, otherwise this thing can break. Some, you know, that glue. What is araldite?
Mhm.
Just put araldite. It will be strong. Then you can plug it. Okay. The thing is very small. I can send the mail version of this one.
Uh-huh.
Then there is another method. Actually, you can keep the FAB and this method. Okay, no problem. Okay, but there's another method you can do. This is not recommended, but still you can do it. So if I draw, this is the FAB connector. Let's say this is OBC. Let's assume OBC is plugged. So the number 1 is connected to number 1 here. Number 2 is connected to number 2 here. So similar way, those are PGC and PGD, MCLR something, MCLR something. Actually, you can plug some jumpers here and access those PGC and PGD.
Mhm.
So, understand?
Yes, yes.
And one more thing, there is a problem here. If I draw the pick it again, so we have the MCLR pin and VDD and ground and PGD, PGC. So it's okay. You can connect the MCLR pin because MCLR reset pin comes here, and then it's okay. You can connect the ground. So then, because anywhere you can access the ground, and then PGD also here, somewhere here, PGC also here, but there so there are, then you need to connect this VDD to 3.3, but you don't have any 3.3 line in the beginning, so you have provided only raw voltage for any of your there are two 3.3 lines in your circuit, 3.31 and 3.32. Initially those things are not enabled, so because of that one you don't have this option. Okay, basically there are two modes of programming. Okay, first mode is voltage sense mode. Okay, and give power mode. Okay, name this mode as give power mode. Initially pick it is in the voltage sense mode. Okay, if pick it don't detect any 3.3 in this VDD line, pick it will give a error. So then what you can do is you can put so if then you go to the second mode. In this mode, pick it provide power from this. Okay, You don't need to connect this one to anywhere. Just tell pick it to give power, okay?
Mm.
Pick it will output power, but the same error happened here will not give.
Oh.
Okay. So
So
basically,
the first one you
you need a
supply power first.
pick it need to sense voltage. So
This one voltage set from the external voltage we
yeah,
supply.
yeah. Then second mode is just give power.
Mm.
Okay, pick it don't detect whether this power is consumed or not. So because of that one, you don't need to connect it here. Okay.
So for second one there is an option
Yeah, I will show how to do it.
supply 3.3 volt.
Okay,
Because
wait, I will show how to do it. So if you come here, so this is our programmer. Then go to this power option. Right now,
Mm.
in the beginning, so this tick is not there. You just need to put this tick. Target circuit from picket 3. Okay,
Mhm.
put this one and from using wait, I need to connect a picket to my one. Then this will show the correct. Wait, I need to find my picket. Give me a few seconds. Uh, because when you connect a picket, this screen little bit change. Okay, so that's why. Okay, so it should come here right now. So it was detected. So now go to power. Now you can see the option here.
Mhm.
Power
Yes.
target circuit from picket. Okay, then here, then from this option, you can select the voltage. Okay,
Yes.
so if I do this one and come here, please don't put any tick here. Okay, this is a different programming option, so it can compute it. In the beginning, don't try that one. Okay, even at the end, don't try. That's a different method. So then, so connect. If you click this one, I don't have any pick connected, so there's an error. So but check here, programmer to target power is enabled, so it enabled power because there's no pick connected. There's an error. Maybe I have something to wait some time. Please give me a few minutes. I'm not minutes, few seconds. Like okay, I have pick. So right now I will connect that pick into my picket. So the pick I connected is not this one. I connected 1788. So then click apply. then go back here. So you have to give power. I will give like something like this. Let's see what happened when I do this one. So things happening here. You have to wait. I'm not sure my circuit will work because I did not turn on this one for a long time. Okay, then you will get this kind of message. Just make it okay. If you want to read, just read. Okay. Now you can see programmer target power is enabled 3.375 and target device found. This was found. And device ID is this one. Then go here and do select the hex file and then program it. Click the program button, so it will take some time. I think I okay. Programming complete. You should see this message. Okay.
Okay.
So the thing is, in the beginning, you must enable this one. Okay. Okay. Let's see what happen if you have not enabled that one. Okay. I have to disconnect and then I try to reconnect it. Okay. Target device was not found. Could not detect target voltage VDD. You must connect to a target device to use PICKIT 3. So it says there's no voltage because in my circuit I did not provide any power. Okay.
Okay.
Understand? So one more thing, if you have to make sure all the line correct order connected and no loose connection. Okay. Otherwise that peak will not be detected properly. And when you program also don't try to touch the lines because you have used jumpers, so you will not, because the connection was not will not be stable enough and it will create a issue. Okay.
Okay.
So please ask if you have anything else.
When you debug your code, do you
Okay.
depends on the UART or
Yeah.
you use
Normally
the debugger in the
using PickIt, using the debugger, you can find the time like every timing and everything. But it's easier using debug serial line.
UART. I mean,
Yeah, just print whatever thing you need to show. So as an example, you can see here when I run this one, it print many things. Actually, because there's no main pick right now in this simulation, you don't see that main pick command. If main pick command comes, so many things will be printed here. How much voltage and that kind of things. Maybe I can show. Basically, we use the serial to debugging.
So you don't really take
Yeah.
attention on the timing.
Ah.
I mean, how long this?
Yeah. This is the case. Currently, I have not like I did not wanted any. I did not want any very good timing. Okay. So if I want like very accurate timing, I will go for that debugging. But for the entire satellite projects I have worked, I have not
Mhm.
get that kind of application.
Mhm. I see.
So, and one more thing, if I want to see like timing, I use oscilloscope. Okay,
Oh,
and the thing
okay.
is, okay, are you familiar with assembly codes?
I forgot already.
Yeah, okay, you have work. Okay, Some- somewhere you have work. So in this compiler, if you want, you can write assembly codes. It's very simple. Actually, I also forgot, but uh, you can just revise if you want to correct timing. So let's say you want to put a assembly code here. Just what you need to do
Oh.
is hashtag ASM whatever assembly and NASM. So
Mhm.
your C and assembly will work together.
Mhm.
Basically, this C code is will be converted to assembly.
Mhm.
So then this will not be converted to assembly. So it is just assembly. Those two will be added together and it will run. And one more thing, I'll show something in very interesting in this compiler. Okay.
Mhm. Uh, just now, previously you said you create a Arduino like serial line command, the serial serial read and serial out,
Uh,
serial write.
maybe I don't have enough
Similar
time.
to
Please,
Arduino.
please
Uh,
wait. I will. Sorry, sorry. Okay, I will explain how the serial line works using a 1 hour video. Okay, I will create
but
that
but
video
but
and
isn't CCS has its own function for this, no?
yeah, yeah, yeah. So this f get c is the you are serial reading. F
Uh-huh.
f foot c. Actually, if you go here in this function, you can see I have maybe here. Yeah, f foot c serial ascending.
Uh-huh.
So but using those function, I created the different advanced functions. So these are those available and read things. So maybe I will explain this one in a different video. I'll send maybe within within 1 week. I will send you
Mm-hmm. Okay,
because
okay.
this is little complicated to explain first time.
Mm-hmm.
And the thing I wanted to show is if you want to see assembly of this one, just go to this view and click this one. So it will show the assembly code of this uh, our created code. So you can see,
Coding.
yeah, if you go here in the end, about 6,000 something lines are there. So wait, the best thing is you can see here the our function unreg one line
Mm-hmm.
as example unreg one line turn on. This is what happened inside the this function.
Mm-hmm.
So
Understand.
yeah, so assembly codes. I don't think you need assembly codes, but sometime I have used assembly inside the main pic in in Kitsune satellite to create a very accurate clock. So I use assembly.
Okay.
In assembly, you know how much time one line takes.
Mm, yes.
So that's why you need assembly sometimes. So as example, maybe you remember. So I told you we have to find how much time it takes to run this loop. So if you use the Pkit debugger, you can find using that one. But the way I found was I use the oscilloscope. No, not oscilloscope. Yeah, oscilloscope to find it.
Okay.
So if you need very accurate timing, you have to use that debugger or that assembly. But see, this is enough. This compiler is very easy to write codes, not like other compilers. It's very easy. In MP Microchip has provided its own compiler called MPLab X to turn on one. Let's say to turn on a LED, you have to write like 5 lines. Here only output high. Okay, so I think it's finished for today. So not I think it's finished. So please create a WhatsApp group. You can
Yes, yes. One last thing. When you powering on the OBC and all this the Cubesat, you you just need to remove the RBF pin, the RBF.
yes.
The other switch.
Just RBF enough.
RBF pin enough.
Yeah, RBF pin, and you need the. Oh, okay. Wait. I need to show that one. In FAB, you need to make this place and this place. Maybe you can see this place, and any of this place ground. Okay. Otherwise, it will not turn on if you use battery connector or external power. Okay.
Okay.
Those are deployment switch.
Deployment
So
switch.
those are in. Okay, so you have to make those ground. Okay. One more thing, this is a safety feature. Okay, so let's say you got a not a safety feature, you need to practice, everyone needs to practice when you get a new board. The first thing I do is, let's say you have, this is your positive supply and negative supply. Let's say you design your board and you got the board. So you have then you get the power supply and connect positive to like this. Let's say if it is 4 volt, you give like this. This should not be done in the beginning. So the first thing I do is, when I get a board, I get a multimeter and put that multimeter into resistance mode, and I connect here. So please check the resistor. Normally it should be kilo ohm range or mega ohm
Definitely.
range. Yeah. If you see like 1 ohm, 10 ohm, 20 ohm, some very less ohm value, or something short circuited here. Okay.
Yes.
So when you connect the power supply, this can get destroyed. So please check those things. Okay.
Okay.
So this is for everyone. It must be that people have in QTech some student damaged some boards because of this one. They did not check and give the power directly after receiving the board.
Yes.
So okay then.
Okay. I think if no more question, then
Yeah, you can
finish.
ask in the WhatsApp group. Please create a WhatsApp group.
Thank you very much, Mr. Tarindo.
Okay. Thank you.
Okay, thank you very much. See you again.
See you.
See you on Google Meet.
Okay,
Bye.
I cannot show my face because camera is not working. Sorry. Okay, bye.
Bye. Thank you.